You ever stop and think about how your browser just finds a website? You type in a name, and bam, you're there. Well, it's all thanks to something called DNS, which is basically the internet's giant phone book. But here's the scary part. What if someone could scribble in that phone book and send you to a fake website to steal your info? That's the exact problem we're talking about today, and the solution is called DNSSEC. We're going to break down why this thing is so important, how it all works, and what you can do to get started with it.
All right, here's the game plan. First, we're going to pull back the curtain on a hidden danger in the DNS system that we all use every single day. Then, we'll meet the hero of the story, DNSSEC. After that, we'll dive into how it builds this amazing, unbreakable chain of trust. And finally, we'll wrap up with a simple 3-step action plan you can use.
Just think about it. You use the internet dozens, maybe hundreds of times a day. And every single time, you're trusting DNS to get you to the right place. It's like this invisible engine humming along in the background. But what if I told you that engine has a critical flaw? A vulnerability that attackers are still using to this day to cause all sorts of trouble. Now, when everything works the way it's supposed to, it's actually pretty amazing. You type something in, and this whole series of servers does this perfectly coordinated dance to find the right IP address. It all happens in less than a blink of an eye. It's a chain of communication. But what happens when a bad guy decides to cut in on that dance? This right here, this is the weak spot. By default, that whole back-and-forth conversation is totally unsecured. It's kind of like shouting a question across a really crowded, noisy room and just trusting the very first answer you hear back. You have no idea who it came from. And this is where things get really nasty. An attacker can jump in the middle, intercept your request, and point your browser to a fake website, one that looks exactly like the real thing. You go to log in, you type your username and password, and boom, they've got your credentials. If that was your banking site, well, you can imagine. This kind of attack is called DNS cache poisoning, and it's a huge threat. So, to fight this exact problem, the folks who build the internet came up with DNSSEC. The easiest way to think about it is like a digital bodyguard for your DNS requests. It stands guard and makes absolutely sure that the answers you get back are the real deal and haven't been messed with. So, what are DNSSEC's superpowers? Well, it makes 3 big promises. First, origin authentication. This means you know you're talking to the right server, not some imposter. Second, data integrity. This makes sure the information didn't get changed on its way to you. And third, this one's a little wild, authenticated denial of existence. It's a fancy way of saying it can mathematically prove that a website doesn't exist, so an attacker can't lie and send you to a fake one. Okay, so we know what DNSSEC does, but how in the world does it actually work? Well, the secret sauce is this idea called the chain of trust. It is a really brilliant method for creating a series of digital handshakes that verify each other, starting from the very top of the internet all the way down to the website you're looking for. The engine that powers all of this is something called public key cryptography. Here's a simple way to think about it. Imagine you have a special, one-of-a-kind stamp that only you can use to put an unbreakable wax seal on a letter. Now, anyone can look at the design of your seal to check if a letter really came from you, but only you have the physical stamp to make that seal in the first place. That's the basic idea here.
Now, to put that idea into practice on the internet, DNSSEC adds a few new types of records to the DNS system. Let's think of these as the main characters in our security story, and each one has a really specific job to do.
Okay, let's really zoom in here, because this is where the real magic happens. First up, you have the zone signing key, or ZSK. Think of that as your special signet ring for making those wax seals. The actual signature, the wax seal itself, is called an RRSIG. Now, how do we know your signet ring is legit? That's where the key signing key, or KSK, comes in. It's like a master key that signs your other key, proving it's authentic. And finally, to tell the rest of the world that your master key is valid, you publish its fingerprint, called the DS record, one level up in the DNS food chain.
And here is how that all snaps together into that unbreakable chain we were talking about. It all starts at the very top, the internet's root zone. That's the ultimate source of trust. The root's key signs a record that vouches for the key for the .com zone. Then, the .com zone's key signs a record that vouches for your domain's key. And finally, your domain's key vouches for the signature on the actual answer you wanted. See? Each link proves the next one is legit. It's a beautiful cascade of trust.
Hey, remember that third superpower, proving something doesn't exist? Well, that's the job of the NSE record. When you ask for a website that isn't real, the server hands back a signed NSE record. It basically says, look,
I can prove that the name you're asking for would fall alphabetically right between these two real names. So I know for a fact it's not here. It's a secure, verifiable way of saying, nope, nothing to see here.
Okay, we've gone through a lot of the why and the how, and I know it can feel a little abstract. So now let's get to the most important part, what you can actually do about it. Getting DNSSEC turned on for your own domain is really just a 3-step process.
So, step 1, you've got to sign your zone. That means creating all those new records we just talked about, the KSK, the ZSK, and all the RSIGs. The good news? Most modern DNS providers will just do this for you with a click of a button. Step 2, and this is absolutely crucial, test everything. Use online tools to double and triple check your setup. Then, once you're sure it's all working, you move on to the final step, publishing your DS record with your domain registrar. And this is maybe the most important part to remember. Steps 1 and 2 are just getting things ready behind the scenes. Nothing is actually live or protected until you publish that DS record. That one little action is what connects your domain to the global chain of trust. It's the Go Live button that turns the whole thing on for the world to see.
You know, when it comes right down to it, enabling DNSSEC is about way more than just protecting one website. It's about taking part in this massive collective effort to make the entire internet safer and more trustworthy for everyone. It's a fundamental upgrade to that core phone book we all depend on.
And that kind of brings us to the final thought. The technology is here, the tools are ready, and the process is pretty clear. DNSSEC is this vital security layer that stops some of the sneakiest attacks out there. So really, the only question left to ask is this: is your domain's chain of trust complete?